Hi everyone, in this lecture I am going to discuss how to find out all the candidate keys from the given relation. First we will see the definition of candidate key. What is a candidate key? Candidate key is a super key but whose proper subset is not a super key. Candidate key is a super key but whose proper subset is not a super key. What is a super key? Whose closure contains all the attributes of the given relation, then it is a super key. Whose closure contains all the attributes of the given relation, then it is a super key. Already I have explained what is super key, what is attribute closure, how to find out the attribute closure and how to find out the number of super keys. Already I explained in previous video. Please check out the video once. So what is a candidate key? Candidate key is a super key whose proper subset is not a super key. Let us assume AC is a super key. Let us assume AC is a super key. When it will be a candidate key? When it will be a candidate key. So, if AC is a super key, what are the proper subsets of AC? The proper subsets of AC are A, C. These are the proper subset of AC. These proper subsets should not be a super key. Then only AC would be a candidate key. So, how to find out these proper subsets are super keys or not? Find out the closure. If you want to find out any attribute or set of attribute is a super key or not, you have to find out the closure. So, you have to find out the A closure and C closure. If A closure and C closure, these two are not a super keys, then AC would be a candidate key. Otherwise, AC not a candidate key. So, candidate key is a super key but whose proper subset is not a super key. I will explain how to find out all the super keys with the example problem. I am taking problem, I am taking relation. This relation consists of A, B, C, D, E attributes and set of functional dependencies. I am taking set of functional dependencies. A determines B, D determines E. These are the set of the functional dependencies. For this problem, we have to find out. For this problem, we have to find out all the candidate keys. For this problem, we have to find out all the candidate keys. So, how to find out all the candidate keys? How to find out all the candidate keys? First, we have to take all the attributes from the given relation. So, what are the attributes in the given relation? First, we have to take all the attributes. So, what are the attributes in the given relation? A, B, C, D, E and find out the closure. So, how to find out the closure? A, B, C, D closure itself determines A, B, C, D, E. An attribute itself determines that attribute. Because of reflexive property, an attribute itself determines that attribute. So, ABCD closure consists of ABCDE. Is ABCD is a super key? Yes, ABCD is a super key. What is a super key? Whose closure contains all the attributes of the given relation, then it is a super key. Here ABCD closure consists of all the attributes. So, ABCD is a super key. ABCD is a super key. Now, we have the next step is we have to discard any attribute from these set of attributes. We have to discard any attribute from these set of attributes. So, how to discard attributes from these set of attributes? Based on the functional dependencies, we have to discard. So, what are the functional dependencies given in the problem? A determines B, D determines C. These are the functional dependencies given in the problem. A determines B means if you have A, then you can determine B. Using A, we can determine B. So, in this set of attributes, I am discarding B. Using A, we can determine B. So, I am discarding B. So, after discarding B, what are the remaining attributes? A, C, D, E. After discarding B, what are the remaining attributes? A, C, D, E. Now, find out the closure. You will check it is a super key or not. If you want to find out any attribute or set of attribute is a super key or not, you have to find out the closure. So, ACDE closure. What is the ACDE closure? ACDE closure first itself determines ACDE. ACDE closure itself determines ACDE. If you have A, then you can determine B. Using functional dependency, A determines B. So ACDE is a super key or not? ACDE is a super key or not? Yes, ACDE is a super key. ACDE is a super key. Why it is a super key? Why it is a super key? ACDE closure consists of all the attributes. So it is a super key. It is a super key. Next we have to discard any attribute from these set of attributes. So this process has to be repeated until no more attribute get discarded. This process has to be repeated until no more attribute get discarded. So can I discard any attribute from these set of attributes? Yes, I can discard E, because D determines C functional dependency is there. Here D determines C functional dependency is there. If you have D, then you can determine E. So I am discarding E. I am discarding E. So what are the remaining attributes? ACD. ACD. Now check this ACD is a super key or not. So how to find out ACD is a super key or not? Find out the closure. Then you will know it is super key or not. So what is ACD closure? ACD closure itself determines ACD. If you have A, then you can determine B. If you have D, then you can determine E. So ACD closure consists of all the attributes. ACD closure consists of all the attributes. So ACD is a super key. Why we have to find out every time it is a super key or not? When it will be a candidate key, first it would be a super key. First it would be a super key, then only it would be a candidate key. So every time we have to check it is a super key or not. Then only it would be a candidate key. So can I discard any attribute from ACD? So what are the remaining attributes? ACD. What are the remaining attribute? ACD. Can I discard any attribute from ACD? No, I cannot discard any attribute from ACD. I cannot discard any attribute from ACD. Now check it is a candidate key or not. Now check it is a candidate key or not. So how to check candidate key or not? So what is a candidate key? Candidate key is a super key whose proper subset is not a super key. Here ACD. Here ACD. ACD is a super key. Yes, ACD is a super key. But when it would be a candidate key, the proper subset should not be a super key. The proper subset should not be a super key. Then only ACD would be a candidate key. So what are the proper subset of ACD? What are the proper subset of ACD? The proper subset of ACD are A, C, D, AC, AD, CD. AC, AD, CD. These are the proper subsets of ACD. So these proper subsets should not be a super key. If ACD would be a candidate key, then these proper subsets should not be a super key. These proper subsets should not be a super key. So how to find out these proper subsets are super key or not? If you want to find out any attribute or set of attribute is a super key or not, you have to find out the closure. You have to find out the closure. So then only you will know the attribute or set of attribute is a super key or not. So find out the closure of all proper subsets. Find out the closure of all proper subsets. So find out if A closure, C closure, D closure, AC closure, AD closure and CD closure. Find out the closure. What is A closure? What is A closure? First A closure itself determines A. If you have A, then you can determine B. So A closure equal to only AB. Is A super key? No. A is not a super key. When it will be a super key? If the closure consists of all the attributes, then only it will be a super key. Otherwise it is not a super key. But here A closure consists of only AB. So it is not a super key. Find out C closure. C closure itself determines C. C closure itself determines C. Can I add any attribute to the C closure? No, I cannot add any attributes to the C closure. C closure consists of only C. C closure consists of only C. So C is not a super key. C is not a super key. Find out D closure. D closure itself determines D. If you have D, then you can determine E also. So D closure consists of only D comma E. So it is not a super key. Next, find out AC closure. AC closure itself determines first AC. If you have A, then you can determine B. So AC closure equal to ACB only. It is also not a super key. Find out AD closure. Find out AD closure. AD closure first itself determines AD. If you have A, then you can determine E. If you have A, then you can determine B. If you have D, then you can determine E. But here there is no C attribute. Here there is no C attribute. So it is not a super key. It is not a super key. Next, find out CD closure. CD closure itself determines C comma D. If you have D, then you can determine E. So CD closure consists of only CDE only. It is not a super key. So the proper subset of ACD, all are not a super keys. So finally we can say that ACD is a candidate key. Finally we can say that ACD is a candidate key. Why ACD is a candidate key? ACD is a super key, but proper subsets are not a super keys. Proper subsets are not a super keys. So that finally we can say that ACD is a candidate key. 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 So after finding the candidate key, now we have to check any more candidate keys are available in the given functional dependency or not. We have to find out any more candidate keys are available in the functional dependency or not. So how to find out more candidate keys from the given relation? For that we have to find out the prime attributes. Prime attributes. So till now we got only ACD candidate key. Till now only ACD is a candidate key. If you want to find out more candidate keys are available in the functional dependency or not, we have to know the prime attributes. You have to know the prime attributes. So what are the prime attributes? What are the prime attributes? The part of the candidate keys. The part of the candidate keys are called prime attributes. The part of the candidate keys are called prime attributes. So first, what is a candidate key? Here candidate key equal to ACD. ACD is a candidate key. So what are the prime attributes? What are the prime attributes? Here prime attributes are part of the candidate key ACD. So these are the prime attributes. These are the prime attributes. So after finding the prime attributes, now we need to check these prime attributes are available on the right hand side of the functional dependency or not. After finding the prime attributes, these prime attributes are available on the right hand side of the functional dependency or not. If the prime attributes are available on the right hand side of the functional dependency, then we will get more candidate keys. Otherwise, we cannot get more candidate keys. Now check these prime attributes are available on the right hand side of the functional dependency or not. So what are the functional dependency given in the problem? A determines B, D determines C. So these are the functional dependencies. If you want to get more candidate keys, then these prime attributes are available on the right hand side of the functional dependency or not. So first prime attribute is A. So now check A is available on the right hand side of the functional dependency. So what is the attribute of the right hand side? Here B, here E. So A is not available on the right hand side of the production or functional dependency. A is not available. Is C available on the right hand side of the functional dependency? Here B, here E. So C is also not available on the right hand side of the functional dependency. D is available on the right hand side of the functional dependency. D is also not available on the right hand side of the functional dependency. So we cannot get more candidate keys. We cannot get more candidate keys. For this problem only ACD is a candidate key. Only ACD is a candidate key. When we will get more candidate keys? If first we have to find out the prime attributes. If prime attributes are available on the right hand side of the functional dependency, then we will get more candidate keys. Otherwise we cannot get more candidate keys. Okay, next session I will discuss one more problem. Okay, thank you.